Electrons carry a negative electric charge. One of the basic rules of electricity is simple, like charges repel each other. When two objects move close together, the electrons in one object begin interacting with the electrons in the other. As the distance between them decreases, the repulsive force between their electrons becomes stronger and stronger. Eventually that repulsion becomes powerful enough to stop the objects from getting any closer. Your hand stops moving, your brain senses the resistance, and your nervous system interprets that resistance as touch, but what you're actually feeling is not atoms colliding. You're feeling electromagnetic forces pushing atoms apart. Even when two objects appear to be perfectly touching, a tiny gap still exists between their atoms. This distance is incredibly small, roughly 1/10 of a nanometer, or about 1/10 billionth of a meter. It is far too small for human senses to detect, yet it is always there, which means something remarkable. At the atomic level, objects never truly make physical contact. Everything is separated by microscopic distances maintained by invisible forces. Everything around you is made from atoms. Atoms are the fundamental building blocks of matter. They form every object you see, touch, and interact with. For a long time, people imagine atoms as tiny solid balls, but that picture turned out to be completely wrong. Atoms are not solid at all. In fact, atoms are almost entirely empty space. The center is a tiny nucleus containing protons and neutrons. Surrounding that nucleus are electrons moving in probability clouds, and these electrons are the key to understanding why nothing ever truly touches. Imagine placing your hand on a wooden table. You feel pressure against your skin. The table feels solid and unmoving. Your brain interprets this sensation as direct contact between your hand and the table, but at the microscopic level, something very different is happening. Your hand is made of atoms, the table is made of atoms. Between those atoms, there is always a tiny gap, but they never actually collide. Instead, something invisible stops them from getting any closer. A powerful force pushes them apart before they could ever truly meet. This invisible barrier is so strong that it creates the sensation of solidity, but the atoms themselves never physically merge. To understand why this happens, we have to zoom into the world of atoms. In quantum physics, electrons obey a strict rule called the Pauli exclusion principle. This principle states that two electrons cannot exist in the same quantum state at the same time. In simpler terms, electrons refuse to occupy exactly the same position and configuration. When atoms come too close together, their electrons begin resisting strongly to avoid overlapping. This resistance creates a powerful quantum pressure. Combined with electromagnetic repulsion, it forms a barrier that prevents matter from collapsing into itself. Because of this rule, electrons organize themselves into stable structures around atoms, and this stability gives matter its shape and form. Our senses evolved to help us navigate the world. They were never designed to reveal the true microscopic structure of reality. To our brains, objects appear solid and continuous, but physics reveals a deeper truth. Matter is mostly empty space. Solidity is created by invisible forces, and touch is not direct contact, it is the sensation produced by atomic interactions. The world we experience is a simplified version of something far more complex. Rather than making reality less real, this discovery actually makes it more fascinating. Every moment you interact with the world, billions of atomic forces are at work. Electrons repel each other, quantum rules organize particles, invisible fields maintain the structure of matter. All of this happens instantly, silently, and perfectly. The universe operates through elegant physical laws that create the illusion of solidity, and once you understand this, everyday experiences begin to feel different, because the next time you touch a table, or hold your phone, you'll realize something extraordinary: your hand never truly touched it at all. The scale of atomic emptiness is difficult to imagine. If an atom were expanded to the size of a huge football stadium, the nucleus would be about the size of a small marble at the center. Everything else would be empty space. The electrons would exist somewhere within that vast region. That means every object around you is mostly empty space: your body, your desk, your phone. All of them are made of atoms that contain enormous empty regions. This raises an interesting question. If matter is mostly empty space, why don't objects simply pass through each other? Why don't our hands slide straight through tables? The answer lies in the behavior of electrons. Think about what this means in everyday life. When you sit on a chair, you are not truly touching the chair. The atoms in your body are being pushed away by the atoms in the chair through electromagnetic forces. Those forces support your weight. In a sense, your body is floating slightly above the chair's surface. The same thing happens when you stand on the ground. Your feet are supported by the repulsion between atoms in your shoes and atoms in the floor. Everything we interact with is separated by these tiny atomic gaps. this repulsion is part of one of the four fundamental forces of nature. The electromagnetic force it governs how charged particles interact. Without it, atoms would not form stable structures, matter as we know it would not exist. Every solid object around you is essentially held together by these invisible interactions between electrons. But electromagnetic repulsion is not the only reason matter behaves the way it does. There is another rule, one that comes from the strange world of quantum mechanics, and this rule makes it even more impossible for atoms to overlap. Touch feels like the most direct experience we have. You reach out and grab a cup, you place your hand on a table, you feel the keyboard beneath your fingers, your brain instantly tells you something very simple: your hand is touching the object. It seems obvious. There is no reason to question it, but modern physics suggests something astonishing. According to our best understanding of matter, no two objects ever truly touch each other, not your hand and the table, not your phone and your palm, not even the ground beneath your feet. It sounds absurd. After all, we feel contact constantly, yet when scientists began studying matter at the atomic level, they discovered something strange about the structure of reality. What we experience as touch may actually be an illusion created by invisible forces, and the deeper we look into atoms, the stranger this idea becomes. What we perceive as a solid surface is actually a balance of invisible forces. When you press your hand against a wall, your atoms are pushing against the atoms of the wall, but they never truly collide. Instead, their electron clouds interact. The closer they get, the stronger the repulsion becomes. Your nerves detect this pressure, your brain interprets the signals, and the sensation you experience is what we call touch. But from the perspective of atomic physics, it is really a complex interaction of fields and forces.
Subscribe Info Beyond Borders now for more mind-blowing knowledge.